Yes. So I mean, we'll have to get back to the campus on 3 days, 6th, 7th, and 8th windows. So it depends on like the travel schedule and all.
I mean, if you can do it on 8th, will it be okay? Because see, otherwise the thing will one may have to have it on a date before 7th.
Yes, sir. No. But the thing is, it might be like people might be coming on train and all. So the availability of transport and all.
No, see let's see how many people have that problem, because say getting it postponed by still further, no, then there could be other issues, right?
Excuse me, sir. One of my friends is coming on 7th, but she'll be coming by train. So she'll be traveling on 6th and 7th. And many are also coming on 8th.
I see. So suppose we have it instead of that, have it on some weekday during that week.
Or can we have it like for a longer duration? I mean, people can spend time for a longer duration whenever they can find time when traveling or something.
No. That doesn't. See, the thing is, I would like to finish the exam for about in about 2 hours time. I don't want to be, and then I have to sort of figure out who has submitted and who has not, and things like that, right? So I don't want to sort of indulge in that.
Sir, is the scanning time and uploading time included in those 2 hours?
No. It will be when you will get some time for scanning and at least 15 minutes after that. And I also give you an email address where you can send.
Okay.
I mean, not CMI, because CMI, this thing you will have difficulty. Wait, just a second. Share screen. Let me. Yeah, CMI. This thing there are problems concerning the maximum limit. It may be just about 2-3 MBs or something like that, and the handwritten thing, and when you scan it, sometimes it might exceed that. Okay, so that is why CMI, this thing means you may have to upload on Moodle. Let us see that. So that is, and I will give you some Gmail address, and you can send it to that. Now, what about the dates? Let's say whoever has objection to that must have, I suppose, written to me. I don't know how many will turn up for today's class. Generally, the attendance has been rather low. So if it gets postponed, I mean, somebody like that day who was attending the class last class, he said that Saturday, the first, I thought I will have it in the first week of November, because that will be more or less the midpoint of our thing. And so I suggested I wanted it to be on Friday, that is the 6th. But then somebody said that the Friday there are classes, so why not Saturday? So okay, so Saturday. So you have been, those who are coming to the campus have been asked to come between 6th and 8th, is it?
Yes, sir.
I see.
Sir, can you repeat what you just said? Actually, I just entered now regarding
the exam. See, some people, it seems the CMI students are required, if those of the students who are coming back to the campus.
okay.
Are expected to do that between 6th and 8th or something like that.
Okay.
So that is the issue. So now what, how one should
Okay, sir. So regarding the midterm of this course, stochastic process 1, so is it finalized on 6th November from 10:30 AM?
I would like to do that, because see, the thing is, if there are such problems, then one has to adjust, right? So how to do it? That's the issue. So, see, I find that very few students attend the class. So some of you have raised the issue. To my message, say I have not checked my email today or yesterday after sending you the message. So I will check my email and see how many are having problems, and then we will be prepared to perhaps have it on some weekday, not Saturday.
Okay.
So that if not on during the first week of November, it would be early second week. That is the week beginning 9th.
Okay.
So
Okay, so basically more or less it is finalized to be on weekdays, means either on Saturday or Sunday.
no, weekdays means Monday to Friday.
Monday to Friday, okay.
Saturday, Sunday.
Okay.
And I wouldn't like to postpone it to the next Saturday. That means that would be 14th of November.
Okay.
So we have to sort of work it out. Okay. I think those of you who told me this, that 7th, this is the problem, have you written, sent an email to me regarding this? The two students who mentioned something today, have you sent an email to me in response to that email concerning the exam? Have you?
No, sir. I thought we will talk about it in class.
Okay. Please send your concerns. Okay.
Okay, sir.
Send me an email, and we will see. And I presume that some other students who are impacted by this and who perhaps are not in a position to come to the class today would have already written to me. I presume that. So then, if it is going to be a weekday, which day would be preferable? That one has to see. Okay. Weekday meaning a day during Monday to Friday. Okay. So if it is a weekday, it can be even before 6th or very soon after 8th. All right. So let us get back to our this thing. Yeah, I presume you can all see this. So this was the last slide of last class. So we had seen that corollary. So today we will look at something what is meant by irreducible closed sets. So what we are aiming at is a kind of decomposition of the state space. So you already know that by definition.
So sir, is it the first slide of today?
Yes, sir.
Okay.
I suppose you would have recognized the last slide of last class, right? That's why I start with generally the last slide of the last class. Okay. So you already know by definition that if a state is recurrent, then it cannot be transient, and vice versa. So already you know that the state space can be decomposed into the set of all transient states, union, the set of all recurrent states, and it is a disjoint union. Okay. So we say a non-empty subset of the state space S is called closed. This closed has nothing to do with the topological sense of closed, which you might have seen in your analysis courses or topology course. Okay. This means the meaning of is given here. That is, basically, if you start from a state in C, you never go outside C. So rho xy, that is the probability of reaching y in finite time starting from x. that probability is 0 for all x in the starting point in C and this y outside of C. So it is closed in that sense. If the Markov chain is in that set C, it never gets out of C. A set C is said to be an irreducible closed set if this set C is closed as per the earlier definition. And in addition to that, the set is irreducible in the sense that if you have 2 points x and y in C, then x leads to y and vice versa, of course. So within that set C, any point is accessible from any other point, and that set is also closed. So those of you who want to note it down, please do. Okay. So please.
Sir, I have a question. So if we take disjoint union of two closed set, so will that be closed?
We'll see soon. Many of these questions will be answered. Some patience, please. Let S sub R be the set of all recurrent states of a Markov chain. And suppose S sub R is not empty. If SR is empty, then all the states are transient. Then S sub R is the union of a finite or countable number of disjoint irreducible closed sets. Of course, you cannot have more than countable because the state space itself is at most countable. Okay, let us begin with the proof. So let us choose some point in SR. So you know that X is a recurrent state. And we define the set C to be the set of all Y such that X leads to Y. That is, all the points Y which are accessible from X in finite time. Of course, you easily can see that X itself belongs to C. Because X is a recurrent state, therefore rho XX is 1. And by the theorem which we have proved last class, so X is in C, and any state accessible from X that will also be recurrent. Consequently, every object Y in this set C will be recurrent state. Every element in C is recurrent state. So C is a subset of S sub R. Please note it.
Sir, actually your voice is quite low. Can you just raise your voice?
Okay. Is it okay now? Better?
Yeah, it is better than before. Yeah,
Yes.
yeah, it is better than before.
Okay. Fine. So now, okay, please note it down if you want to. So we claim that this C, which we have defined this way, is an irreducible closed set. So first we will show that C is closed. So that means starting from any point Y in C, any other point which is accessible from, or which you can reach from Y, will also be in C. Okay. So let Y be a point in C and let Z be accessible from Y. That is, Y leads to Z in finite time. We have already shown C is contained in S sub R. So every state in C is a recurrent state. So Y is a recurrent state. Consequently, by the theorem, the last theorem we proved in the previous class, Z is also recurrent. Since X leads to Y and Y leads to Z, one can show that X leads to Z. So consequently, Z is also an object in C by the definition of our set C. So C is closed. Okay. Next, we will show C is irreducible. Suppose you take two elements, Y and Z in C. These are Y and Z may have no relation with the Y and Z in this part of the proof. So let Y and Z be two elements in C. So since X is recurrent, because the set C is manufactured out of X and X is a recurrent state, as X is recurrent and X leads to Y by that theorem 3, the last theorem, it also follows that X is accessible from Y. Y leads to X. So we have now Y leads to X and X leads to Z because Z belongs to C, and hence Y leads to Z. Consequently, the set C is irreducible. So the claim is proved. Note it down if you. Okay. Now, to complete the proof, so our claim is that S sub R is the disjoint union of a finite number or a countable number of irreducible closed sets. So, if E and D are two irreducible closed subsets of S sub R, then either they coincide or they are disjoint. Okay. So, to prove such statements, usually what one does is one assumes that this doesn't hold. That E intersection D is not empty. And from that, one derives the thing that D is contained in E and E is contained in D. Okay. So suppose E intersection D is non-empty, which means there is a X which belongs to the intersection. So now choose any arbitrary point in E. So now, since E is irreducible and X is a point in E and Y is a point in E, X leads to Y. And since X belongs also to D and D is a closed set, it follows that Y belongs to D. So Y we have taken to be any arbitrary point in E, and we have shown that point is in D. So this means E is a subset of D. So in an exactly similar way, you can prove D is subset of E. So this completes the proof of the proposition.
Sir, can you show the main result which you're trying to prove?
We have proved.
Means, can you show me the statement of the?
Yeah.
Okay.
I thought you had noted it down.
Yes, it is okay, sir. Okay, sir, fine.
Now, the result we just now proved, together with some of the earlier results which we have proved, gives rise to some kind of obvious consequences. I'm going to talk about that. Before that, I want to sort of to make that thing in a good perspective. Yeah. Suppose C is an irreducible closed set. Okay. This means if you start from C, you cannot go outside of C. Rather, if the Markov chain starts from C, it cannot go out of C. And inside C, it is irreducible. So consequently, the Markov chain which Xn, which is defined on S, if the starting point happens to be a point in C, then that just keeps inside C. So in other words, Xn restricted to C itself is a Markov chain, irreducible Markov chain with C as state space. Okay.
So sir, basically means irreducible closed sets are in some sense minimal kind of thing. Means no proper subset of C is a closed set.
Sort
Can
of.
we?
Yeah.
So am I right?
Yeah. I mean, you are sort of right, but irreducibility is important. Otherwise, the whole point is lost.
Yeah. No, means what I am trying to say, if we take a closed set C which is minimal, then that will also be an irreducible closed set.
There is nothing called minimal. Any irreducible closed set is a small unit in which the thing is a Markov chain. Don't bring in unnecessary words which may have other kind of implications. Okay.
Okay.
So I think we can say that if C is an irreducible closed set, is the smallest closed set containing X.
Sort of, yeah, but see, so that kind of hair splitting. See, the thing is, main thing is you should get the big picture. Okay, the state space basically that is divided into smaller pieces, and the Markov chain restricted to those smaller pieces by themselves is they are Markov chains. In other words, the Markov chain on S is, or rather the Markov chain restricted to S sub R. Okay, S sub R is sort of made up of if that number of that many smaller Markov chains. See, the problem set I will be setting you today, there is one exercise which concerns this. You will see small the example concerning finite state space. You can see that kind of a picture. Okay. All right. I mean, as far as possible, don't bring in more terminologies. Okay. All right. So some useful and these are useful and obvious consequences. So yes, we have noticed that S can be written as S sub R union S sub T. S sub R is the set of all recurrent states, and S sub T is a set of all transient states. And clearly these are disjoint by definition of recurrence and transient. Okay. And in addition, the preceding proposition, we had proved that S sub R can be written as C1 union C2 union etc., where each C sub k is an irreducible closed set of recurrent states. Also, these CIs are disjoint. Okay, please note it down if you want. All right. So suppose the process starts in one of the CIs. Let us say C1. Then it stays in that C1 forever, or that CI forever. And the CI is an irreducible closed set. So every state is accessible from every other state inside CI. And Also, since every element in CI is recurrent, from our earlier results, that theorem 3, theorem 2, all these things together, you conclude that if the process starts in CI, it stays there forever. Not only that, it visits each state in that CI infinitely often with probability 1. So in other words, if X and Y are 2 points in CI, then the probability that Xn equal to Y for infinitely many n, given X0 is equal to X, is 1. Okay, note it down if you want. Okay. So this takes care of if the process starting from any of the recurrent states, because any recurrent state will be one of the CIs. All right. Suppose it starts from a transient state. Then it stays in that ST, that is stays in ST forever. For example, that happens if the number of transient states is infinite. It can be moving only among transient state and each state visiting only finitely many times and things like that. But a transient state can lead to a recurrent state. So if it starts from ST, then it either stays in ST forever or it moves to one of the CIs in a finite number of steps and stays in that CI ever after. And in that CI, it visits each state in that CI infinitely often with probability 1.
So, sir, when can it stay in ST forever?
Invariably, when that there are infinitely many transient states. We will soon see examples of a Markov chain which is transient.
Okay. Okay. But so if there are finitely many transient states, then it will go to CI at some point of time.
No, if it is finitely any state, supposing the state space is finite. Okay. Then we will prove there should exist at least one recurrent state.
Okay. No. I am saying that if the number of transient states is finite, then it cannot stay in ST forever.
Correct. You are right.
Okay, fine. Okay. But if ST is infinite, then either it can stay or it can go to some recurrent state.
Yes, sure.
Okay, fine.
So that finishes this part of our thing. So this I will upload it today. So I will stop sharing this and then go to the other next one. Okay, which means I have to stop sharing and go back and get the other one. All right. So all right. So you can, I suppose all of you can see this. Okay. So now we will consider recurrence transients of birth-death chains. Okay. First, we will look at unrestricted birth-death chain. So recall that the state space is the set of all integers, positive, negative, and 0, of course. And also P sub I plus 1 is little pi, P sub I minus 1 is little qi, and Pii is Ri, which is nothing but 1 minus Pi plus Qi. So that means Pi plus Qi plus Ri is equal to 1. Pi and Qi are required to be strictly positive. And Pi plus Qi should be less than or equal to 1. Ri can be 0. If Pi plus Qi is equal to 1, then for that Ri can be 0, will be 0. So since each Pi and Qi is strictly positive, you can verify that the Markov chain Xn is irreducible. So if the Markov chain is irreducible, we have seen that either, I mean, if there is a one recurrent state, every other state is recurrent, and vice versa. I mean, and so if there is one recurrent state, every other state is a Markov chain itself is recurrent, and if there is one transient state, then the Markov chain itself will be transient. But I think that was the corollary which we had seen in the last class for irreducible Markov chains. Okay. So now let C and D be two elements in Z. Since any two integers can be compared, let us say C is strictly less than D. So we consider the event X sub n reaches C before reaching D. When basically the starting point I is between C and D, C, D included.
Sir, I have a question. So here I should be strictly less than D, right? Because if I equal to D, then initially it is in the same state D, but you have defined the event as it reaches C before reaching D.
Yeah, so it has reached C before reaching D, no?
No. I am saying the bound I should be greater than equal to C less than D. Means the starting state I should be strictly less than D, because if it is exactly D, then
if it is exactly D, then this probability is already 1. I mean, sorry, 0.
Okay.
I am not saying hitting.
Okay, sir, got it, sir, got it, fine.
You have got a point that soon you will see what you have. Your apprehension is well founded, okay? So just this comment regarding notational thing, this event E as well as this function psi, they depend on C and D, which sort of act as parameters. If we take different C and D, these functions could be, and this E will be different. But we do not indicate in the notation because of convenience. Okay, you should keep in mind this. So this thing you see psi of C is 1, because if the starting point is C itself, then this psi of C is 1. It's already in C. And similarly, psi of D is 0. Please note it down. So, in other words, this is a function of I. And this function is defined for every I between C and D, including at C and D. And we can easily see these two values. So in other words, the value of the function is given at these two boundary points. So the idea of our approach is using these boundary values, and we are going to find something about the psi I for the values in between. One should try to get an expression for psi. So that way your question serves some purpose. Please note it down if you want. So now you see, whenever the starting point is that I is strictly between C and D, then this event E can be written as TC strictly less than TD, where TC and TD are respectively the hitting times of C and D, but first hitting time. So consequently, psi of I is the probability TC strictly less than TD given x0 equal to I, that in our notation we have been using P sub I of TC less than TD for I between C and D.
Sir, what is PI of TC less than TD?
That is something as this. This is notation. Go back to your notes, earlier notes, and see.
Okay.
This thing is a kind of short notation for this.
Okay, sir. Okay, sir. Okay, sir. Okay, sir.
Please bring all the notes you have taken down earlier. Okay. So what we are going to do is, we are going to start from a point I in between C and D. So by definition of hitting time, or even just using common sense, the event E can occur only at times n greater than or equal to 1. Because at n equal to 0, it is at I, which is strictly between C and D. Okay. So by definition of psi, it is a probable psi of I is probability of E given x0 equal to I. So now in the very first step, from I, you can go to I plus 1 or I minus 1 or stay in I itself. So you can easily see this is P sub E given x0 equal to I and x1 equal to I plus 1 multiplied with the probability of reaching I plus 1 from I in one step. That is P sub I plus 1. And similarly, the first step, if it happens to come to I minus 1, it will be like this. P of E given x0 equal to I, x1 equal to I minus 1 multiplied with Pi I minus 1. And of course, the third possibility is P of E given x0 equal to I and x1 also equal to I, Pi.
So there is a missing plus sign here.
Yeah, sorry. Yeah, thanks a lot.
There is and also in the second equality, there is also missing plus sign.
Yeah. Thanks a lot. That's an error. Because of course, the plus suddenly mysteriously appears here, right? The missing pluses appear here. Very good. So yeah, there should be a plus here as well as a plus here. Yeah, good. You are alert. Yeah, I'm very sorry for it. So now use the Markov property. So this, once you have this information becomes irrelevant. Then it is same thing as probability of E given x0 equal to I plus 1. And similarly here. And by our definition of the function psi, this is psi of I plus 1. The second, this thing is the qi times, I mean, psi of I minus 1. And this one is psi I. And these are these probabilities are Pi, Qi, Ri. So now you see that there is a psi I here and a psi I here. And we also know that Ri is basically 1 minus Pi plus Qi. Please note it down. When you note it down, please with the plus signs.
So basically, we have to solve this recurrence for psi I.
Yeah, just wait. It is just see the proof, how it develops. Okay, next slide. So for every I between C plus 1 and D minus 1, that is I strictly between C and D, we have this equation, which we call it as dagger. And using that, the P sub L, Q sub L, or sub L, they together sum up to 1. From this dagger, you verify that psi I plus 1 minus psi I is Qi divided by Pi times psi I minus psi I minus. For all I strictly between C and D. Okay. Note it down if you want to. So now you iterate this. So you have got this. Now since you know this, you can write that in terms of psi I minus 1 minus psi I minus 2, etc. doing that, you will get psi x plus 1 minus psi x. All these ratios would get accumulating, okay, product of these ratios. And one has to carefully keep a count of which all ones will occur. So for any x between c plus x and d minus 1, define this theta x to be this product of these p's, qx over px, 2x minus 1, etc., etc. Basically, you are coming from the right to left. So x is coming from x2 or x plus 1 to c plus 1. That is. And now sum over the x varying over y plus 1 up to d minus 1. So when you do that, you are going up to d minus 1. So in this thing, that will correspond to d. If x is equal to d minus 1, this would be d, yeah. And your starting point is y. So this will be psi of y. And you are summing. So this is equal to this sum. So which in terms of our notation, psi of c plus 1 minus psi c, and this theta x added from y to d minus 1. So first thing is, our idea is to get psi of c plus 1. Okay. So put y equal to c plus 1 in that double dagger. And use the information that psi of c is equal to 1 and psi of d equal to 0. So this would disappear. And here you have this, and so on. And then you just note what you get. Some little bit of manipulation may be required. And that is equal to psi, that is minus of negative of psi c plus 1 equal to psi c plus 1 minus 1 times this sum, where the summation is going from c plus 1 to d minus 1. So using from this, it's a simple calculation to get that psi of c plus 1 is equal to 1 divided by this multiplied with this thing again here. In other words, one has been able to find psi at c plus 1. Psi at C we know. Now psi at C plus 1. And using the double dagger and this, again, yeah, elementary manipulation will give you psi I, y, psi of y for every y between C plus 1 and D minus 1. For example, if you put y equal to C plus 1, you get this expression. The difference is lying here. I will stop here today. The whole purpose of getting this thing, so we have solved for that psi. So purpose is to get rho sub yc for y greater than c. We will look at it the next class. This is a reasonable point to stop.
So what will you do in the next class? Can you repeat?
See, using the information we have got up to here, we will try to have some information concerning rho sub yc. That is, rho sub yc is for a point y which is strictly bigger than c. Starting from a point y, the probability of coming to c in finite time. That is rho sub yc.
Okay.
Ultimately, the idea is to get some criteria in terms of the PIs, QIs for recurrence and transients.
Okay. So basically, in this example, C and D, they're the parameters for the function psi.
Yes, but that the CD will disappear soon.
Okay. Fine.
Not soon, but as to sort of we are going towards that. Okay, I will stop sharing. Okay, so whoever has responded to my this thing concerning exam, I will look at it, and if there is going to be a change of date, then you may have to be prepared to have it on some possibly a working day. I would like to avoid the Saturday after that, because that would be postponing it by one more week. Of course, if there is no other choice, then one may have to do that.
So, sir, have you sent any mail regarding the choice of the exams of the midterm?
I have sent you an email yesterday. That's why some of you are raised some issues about that.
Okay, fine.
Okay, we'll end the session.